What do you do when the evidence doesn't match the explanation? When the stones are too precise, the alignment's too perfect, and the tools supposedly used couldn't have done the job? This is ancient cipher, and today we ask the question nobody has fully answered. There is a category of ancient structure that does not announce itself as astronomical. No inscription declares its purpose. No surviving text explains the intention behind its orientation. And yet when modern astronomers and archaeologists point their instruments at these monuments, measuring angles, tracing sightlines, mapping alignments against star charts reconstructed for the sky as it appeared thousands of years ago, what they find is not coincidence. What they find is precision. Deliberate, repeatable, technically demanding precision. Alignments to solstices, equinoxes, stellar risings and lunar cycles that required sustained observation of the sky across generations, mathematical frameworks capable of encoding that observation into physical space, and construction techniques accurate enough to translate that mathematics into stone at scales ranging from meters to kilometers. The civilizations credited with these structures did not, according to the conventional record, possess telescopes, written astronomical tables, or the institutional continuity of a formal scientific tradition. And yet the alignments they left behind in stone have been confirmed by modern astronomy to be accurate, in some cases to a degree that challenges the assumed limits of naked eye observation. How did ancient builders encode astronomical knowledge of this precision into structures of this scale? And what does the knowledge itself tell us about how far back sophisticated skywatching actually goes? The most visited megalithic site in the world is also one of the most misunderstood in terms of what its astronomical alignments actually demonstrate. Stonehenge stands on Salisbury Plain in southern England. Its construction occurred in multiple phases spanning roughly 1,500 years, beginning around 3000 BCE and continuing through approximately 1500 BCE. The structure most people recognize, the iconic ring of standing sarsen stones with their horizontal lintels, represents a late phase of a much longer and more complex building history. The most widely known alignment at Stonehenge is its orientation toward the midsummer sunrise. Standing at the center of the monument on the morning of the summer solstice, the sun rises directly over the heelstone, positioned outside the main circle along the avenue, a processional approach aligned with the same solar event. This alignment has been confirmed repeatedly by modern astronomical analysis and is not disputed. What receives less attention is the precision required to achieve it. The heelstone is positioned approximately 78 meters from the center of the monument. The solar azimuth of midsummer sunrise shifts slightly from year to year due to the obliquity of the ecliptic, the gradual change in the tilt of the Earth's axis over millennia. Researchers calculating backward to the period of Stonehenge's construction have confirmed that the alignment was accurate for its time, meaning the builders were not simply pointing a structure vaguely northeast. They were encoding a specific astronomical moment with enough precision that it has remained measurably correct across thousands of years. The complication deepens when the lunar alignments at Stonehenge are examined. The monument's geometry encodes not just the solar year, but the 18.6-year lunar standstill cycle, the period over which the moon's rising and setting points on the horizon complete their full range of movement. Encoding this cycle in stone required continuous sky observation across at least 2 full cycles, meaning a minimum of roughly 37 years of systematic astronomical record-keeping before the first stone was placed in its final position. That is not casual skywatching. That is institutional science, practiced by a culture that left no written records and no surviving instruments. Roughly 9,000 kilometers southeast of Salisbury Plain, in the Egyptian desert near the Sudanese border, there is a site that predates Stonehenge by thousands of years and encodes astronomical alignments that most people have never heard of. Nabta Playa is a dry lake bed in the Nubian desert that was, between approximately 11,000 and 5,000 years ago, a seasonal lake fed by monsoon rains. The people who gathered there during the wet season left behind a complex of stone alignments, burial tumuli, and what researchers have identified as a stone calendar circle, a ring of upright stones with specific pairs aligned to the summer solstice sunrise and to the stars Dubi and Arcturus as they appeared in the sky approximately 6,000 years ago. The site was identified and analyzed by astrophysicist Thomas Brophy and astronomer J. McKim Malville, among others, whose work proposed that Nabta Playa's stone alignments represent one of the earliest known examples of astronomical encoding in megalithic architecture, predating Stonehenge's construction by over 1,000 years and located in a region of Africa that is rarely included in mainstream discussions of ancient astronomical knowledge. The complication at Nabta Playa is not simply the age. It is the sophistication of the stellar alignments relative to the assumed developmental level of the pastoral nomads credited with the site. The alignments require knowledge of specific star positions at specific times of year, knowledge that implies sustained, systematic observation rather than the opportunistic sky-watching of a mobile population focused primarily on survival and seasonal migration. Why were nomadic pastoralists encoding stellar alignments in stone in the Nubian desert 6,000 years ago? What tradition of sky observation were they drawing on? And why does this site remain so little known compared to the European megalithic tradition that came after it? Pause here, because across these first two sites a pattern is already forming that will continue through every structure that follows. The astronomical knowledge encoded in these monuments is not decorative. It is not approximate. It is precise enough to have been confirmed by modern astronomy using tools and methods unavailable to the original builders. And in both cases, Stonehenge and Nabta Playa, the precision required a duration of systematic observation that implies an institutional tradition of sky-watching stretching back generations before the construction itself began. How far back does that tradition go? Where did it start? And what happened to the accumulated knowledge it must have produced? On the Yucatan Peninsula of Mexico, the Maya city of Chichen Itza contains a structure whose astronomical engineering has been confirmed so precisely that it draws crowds twice a year from across the world. El Castillo, the Temple of Kukulkan, is a stepped pyramid approximately 30 meters tall, with 4 stairways of 91 steps each, plus the top platform, totaling 365 steps, the number of days in the solar year. Each of the pyramid's 4 faces is oriented to a cardinal direction with a precision confirmed by modern survey instruments to be within fractions of a degree. On the spring and autumn equinoxes, as the sun descends toward the horizon in the late afternoon, the angle of light and shadow on the northern staircase creates a series of triangular shadows along the balustrade that produce the visual effect of an undulating serpent descending from the temple summit to the serpent head carved at the staircase base. The phenomenon lasts approximately 45 minutes and has been confirmed as intentional by researchers who have analyzed the precise orientation and geometry of the structure's faces. Producing this effect required the Maya architects to understand not only the solar azimuth at the equinoxes, but the specific angle of solar elevation at the latitude of Chichen Itza during the relevant period of the afternoon, and to translate both pieces of information into the exact slope and orientation of the pyramid's faces with sufficient accuracy that the shadow effect occurs predictably every year, 1,000 years after construction. The complication is not the Mayas' astronomical capability. Their astronomical tradition is extensively documented and represents one of the most sophisticated, naked-eye astronomical systems in the ancient world. The complication is the engineering translation. Converting astronomical knowledge into architectural precision at this scale, without modern survey instruments, requires a computational and practical methodology that has never been fully reconstructed or demonstrated experimentally. The island of Sardinia in the Western Mediterranean contains over 7,000 stone tower structures called nuraghi, built between approximately 1800 and 500 BCE. Most have received limited archaeological attention. A small number have been identified as having significant astronomical orientations, but one site in particular stands apart from the rest. Su Nuraxi di Barumini is the largest and best preserved nuraghi complex on the island and a UNESCO World Heritage Site. Recent archaeoastronomical analysis of the central tower's entrance orientation has identified an alignment to the rising of specific stars associated with the Pleiades cluster, a stellar group whose heliacal rising was used across multiple ancient cultures as an agricultural and calendrical marker. What makes the Sardinian nuragic tradition significant in the context of astronomical architecture is its relative isolation from the major megalithic traditions of the Atlantic coast and the Mediterranean East. The astronomical orientations at Su Nuraxi appear to have developed independently, a separate convergence on the same practice of encoding sky knowledge in stone that was occurring simultaneously in Egypt, Britain, Mexico, and elsewhere. That convergence, the appearance of the same basic practice across cultures with no confirmed contact, is one of the more quietly remarkable patterns in the archaeoastronomical record. Independent invention is the standard explanation, but independent invention of the same precise technical practice in the same architectural form across multiple continents and multiple millennia is a coincidence that some researchers have found increasingly difficult to accept without further examination. The fifth and final structure in this examination sits in the Orkney Islands off the northern coast of Scotland and is, despite its significance, visited by a fraction of the tourists who make the journey to Stonehenge. The Ring of Brodgar is a henge monument approximately 104 meters in diameter, originally containing 60 standing stones, of which 36 survive. It forms part of a larger Neolithic ceremonial landscape that includes the standing stones of Stennis and the settlement of Skara Brae, a complex that has been described by some researchers as a Neolithic equivalent of a regional ceremonial center. Archaeoastronomical analysis of the Ring of Brodgar has identified alignments to major lunar standstill events, the same 18.6-year lunar cycle encoded at Stonehenge, appearing here in a monument that predates the Sarsen phase of Stonehenge and sits at a latitude where lunar behavior at standstill is particularly dramatic, with the moon at its southern extreme appearing to skim the horizon rather than rise and set in the conventional sense. The precision of the lunar alignments at Brodgar, combined with the evidence of sustained Neolithic activity across the Orcadian ceremonial landscape over a period of centuries, points toward the same conclusion that every other site in this examination has suggested: a tradition of systematic astronomical observation, encoded in stone with technical precision, operating across the British Isles and beyond for a period far longer than the monuments themselves represent. 5 structures, 5 separate cultures and regions, and in each case the same fundamental characteristic: astronomical knowledge encoded in stone with a precision that required sustained observation, mathematical frameworks, and construction accuracy that the conventional record struggles to fully account for. How did ancient builders encode astronomical knowledge of this precision into structures of this scale? The answer that the physical evidence consistently points toward is one that archaeoastronomy has been building toward for decades. The knowledge was not invented at the moment of construction. It was inherited, accumulated across generations of systematic sky observation by traditions that predate the monuments we can still see. The stone structures are the endpoints of a knowledge tradition, not its beginning. How far back that tradition actually extends, how many generations of careful, patient sky watchers looked up before the first stone was placed in alignment with what they saw, is a question the monuments themselves cannot answer. They can only confirm, in the precision of their alignments and the durability of their construction, that the knowledge was real, that it was deep, and that somewhere behind these 5 structures and the dozens like them scattered across every inhabited continent, there is a history of human intellectual achievement that the written record has not yet fully recovered.